everybody who is watching this video. My name is Olenjolai TAYAI Singo from beautiful country called United Republic of Tanzania, eastern of African continent. This is our national flag. You are warmly welcome in Tanzania. We love our guests, all foreigners. First of all, before even introduce you what I've prepared today, I would like to, I'm very sorry for my voice box today is not good, but I'll be trying my level best to pour out what God has put in me in order to change your life or transform your life from one point to another point. So I would like to take this fantastic moment to meet with you through the video, digitally, and through the internet, to welcome you into our fantastic online undergraduate Polytechnic Institute of Tanzania, in square bracket is Olenjolai. Simultaneously, because we are mathematicians, I would like to welcome you onto one of our official YouTube channels that called the Online Undergrad Polyinstitute of Tanzania, in square bracket OLENJOLAIM. This is the abbreviations of undergraduate, abbreviations of undergraduate, and Polytech, and this word Polyinstitute are the abbreviations of Polytechnic Institute of Tanzania, in square bracket OLENJOLAIM. I would like to spend a few minutes to remind you the vision, because remember that visions is very powerful, right, in life. So the vision that God has revealed in my heart, in order to do this fantastic national, international, and international programs, which is called the Online Undergraduate Polytechnic Institute of Tanzania. This is the vision that in my mind, and I would like also to write to you who is watching this video at this moment. So when we combine together the elements that has been hidden in our heart or in our soul, then we change the world, and we change our own country, and we solve our own real life problems. So the vision is this one. I would like to be a part of teachers who prepare undergraduate students, right? Undergraduate students who are serious, passionate, and visionary, who are ready to take engineering concept, the knowledge they learn in the classroom in engineering mathematics and scientific mathematics, including their, we call them core modules or core course or subject, classroom instruction, for example, in telecommunication engineering or in electrical engineering, and you combine that classroom instructions with the spiritual knowledge of Word of God. And then the next step, you know what is going to happen? You have to solve at least a single real life problems, or more than one real life problems. So our main objective in this program, we like to see our students, we'll be training them, right? It's a process. It's not just within a second and then become competent on solving real life problems. It's a process. It might take even sometimes a year or 2 years, but don't worry about the timing, because sometimes preparation time might be longer than the time of working, but the impact is great for those who used to get well preparations rather than those who used to do poor preparation. So our main objective in this, our main objective in the Online Undergraduate Polytechnic Institute of Tanzania is to see our continuing student, right, studying our continuing student, solve real life problems while they are still at their institutions or colleges or universities. And even after they graduate, they should have a hunger, right? They should have a hunger and be angry to solve real life problems, because that's why we used to go to the colleges or to the universities, in order to get knowledge and solve our real life problems. So we have we have many specific objectives in these online programs. Would you like me to share a few? Yes, one of them would like to help and equip every of our students, whether slow learner, intermediate learner, or faster learner, in order for them to pass their continuous assessment and even the final exams. That is one of our specific objectives. Our second specific objective, which possibly might be your main objective, is we would like to see our students graduating successful, and they have to receive a reward or an award of certificate. That's our second specific objective. But our third specific objective is we like to see all our students, whether they dislike the mathematics, they have never loved mathematics, to love mathematics because it's the queen of engineering. And this is the warning. Olenjolai does not know everything about engineering and scientific mathematics, but Olenjolai knows a small portion of the brain. But this is the character that God has created in him, that he is ready, Olenjolai is ready to teach anybody what he knows. So I'm ready to teach anybody what I know. So that is a brief introduction that I would like to share. In case that you want to get detailed introductions concerning vision, problem solving, and because myself I'm solving a problem and it's a national problem. Okay? So I don't mean that I boast myself, but by the grace of God I'm solving a national and the international problems right now. So this teaching, teaching entrepreneurship. Okay, so that is the piece of information. Remember that to watch, we have a lecture titled as Lecture 00. So for you who is in TCU, under TCU, you have to watch several of those videos because they give you the general introductions, the visions and the mind and the forecast and where we're heading to. So make sure that you watch it before you come along this lecture 1. So also I would like, so we have some departments in this online institution. One of the departments is called Higher Engineering and Scientific Mathematics. Say it, Higher Engineering and Scientific Mathematics, right? And the modules of the course that we have today is MT161, Matrices and Basic Calculus. This is we call it freshman, okay, freshman in the United States of the freshman course, or freshman fundamental course, right? Or we call it, yes, fundamental course. And this is under TCU, and I will be using the syllabus or the curriculums of University of Dar es Salaam in abbreviations called Udsm. Okay, so in this department we are teaching 12 modules or 12 courses, right? So it means that 4 courses is from, I'm using the syllabus of University of Dar es Salaam as the reference, but this is a national and even international concept that we are going to cover. But also I'm teaching 4 courses or 4 modules under NACTE, National Council of Technical Education, and I'm using the syllabus of Dar es Salaam Institute of Technology. And I'm also going to teach you 4 modules or 4 subjects. And I'll be using the syllabus of the biggest university in the United Republic of Tanzania, that's called University of Dodoma. So remember that this material, mathematics is universal, and these materials are relevant for anybody in this world, and can help either an engineer, mathematicians, or a scientist to think differently. That's what I'm going to teach you, to think differently. But our primary focus is using the curriculums and the syllabuses of United Republic of Tanzania. So if you're Tanzania, you're in the right place, and get prepared to be transformed. So let us go to the lecture. So we have lecture 1, and this lecture, before lecture 1, in these modules of matrices and basic calculus, so I'd like just to say the quick review. So quick review, I want to link this session with the previous session, right? This is my quick review. So you have to watch session 00. In session 00, I did the following. Number 1, I presented to you about vision. Vision of what? Vision of Online Undergraduate Polytechnic Institute of Tanzania. And the founder is Olenjolai. Okay? So that's the first thing. Secondly, again, I introduced to you about our YouTube channel, right? Our YouTube channel. So it means intro of our YouTube channel. So what I did here, I did the intro, right? And our YouTube channel is called Online Undergraduate Polyinstitute of Tanzania, square bracket OLENJOLAIM. Again, I introduced about registration. Registration, okay? Registration, right? Registrations and consistency, right? And the consistency, right? This is the digital platform. But again, I spoke about the big picture in mathematics. What big picture? What the big picture that God has put in my mind, in maths, right? And then, thirdly, another concept also, another thing that I have presented to you, I presented about reference books. What are the reference books? Text, I call it text, question, and answer books. Okay, I mentioned more than 6 reference books, so you have to watch them. And then I came to the universities, or I clarify also about TCU, what the difference is not equal to the NAT, right? So if you want to know the difference, then you have to go there. Then I mentioned some of the universities that some universities, right? Some universities study what you study, let's say MT 161. And then finally, I presented contents or topics. Okay, so I presented topics of 40 of basic calculus and matrices. So make sure that you go through that video before we move on. So in this lecture, so we have the first topic that I'm going to teach you is called the vector algebra. Say vector algebra. Say vector algebra. Say vector algebra. Say vector algebra. Okay. So before even I mention about some of the details, I would like just to say that, so I would like just to remind you, some universities, right? Some universities, first of all, okay, remember that we have, this is Tanzania, right? I would like to begin at this point. This is United Republic of Tanzania. In Tanzania, for higher education, we have 2 authorities, right? We have, we call Tanzania Commission for Universities, in abbreviation is TCU. And also we have National Council for Technical Education. Well, before even explaining TCU and NATE, I would like to take this moment to welcome. I know that you are first year undergraduate student. Welcome to enjoy the beauty of engineering and scientific mathematics. And also welcome to enjoy the learnings, just 3 things, engineering and scientific education, okay? And then applications of science that have been studied from primary education until you are Form 6 or ordinary diploma. And then welcome to enjoy the beauty of problem solving in engineering, because engineering is the purpose of use of 40 of science, right? And then get prepared to change the world and the community and the present and future generations. So you're welcome, okay, you're welcome, TCU, NATE. Okay, so this one, it means that the focus of the curriculum and the syllabus of TCU is this, we say that it focuses on a concept that we call knowledge-based, right? Knowledge-based. And then this one, the focus of this authority is competence-based. So competence-based, right? So just to mention some of the universities, they study these models of 40, some of the universities are connected. We have University of Dar es Salaam, Udsm. You have also University of Dodoma, UDOM, right? We have also St. Joseph University in Tanzania, right? College of Engineering and Technology. Also, we do have another institutions we call it Zanzibar State University, right? In Zanzibar. And then also we have some other universities, for instance, Kampala International University in Tanzania, CUT, right? Kampala University International in Tanzania. And then so 1, 2, 3, 4, 5. So you can even keep on listing. But we have again another university, we call it the United African University of Tanzania. The United African, okay, University of Tanzania, UAT. So those are the same. But let me mention the 7th one. The 7th ones also, we have, these are the engineering institutions in Tanzania or universities. We have the African University of Tanzania. African, we have none. So we have RD University, AU. So I mentioned at least 7, but there are more than 7 universities. These are just examples. Again, at NATE, remember that the leading one is Dar es Salaam Institute of Technology. The second one, okay, after Dar es Salaam Institute of Technology, is Mbeya University of Okay, Bear University of Science, and what? And Technology. Then the third one is Arusha Technical College. Then the fourth one is Al-Mutar Universities. But against you have Karume Institute of Science and Technology. Okay? Then we have the other ones, the next ones, and Anate, which are offering what? Undergraduate education in what? So let me leave you, these are the whole. So because I'll be speaking under the TCU, these are the examples. So we say that this is the first one, the second one, the third one, the fourth one, the fifth, the sixth, and the seventh university. So according to, if you're studying this, these are some examples. So you say that according to my research, okay, according to my research in Educational University of Tanzania, we say that all universities or colleges, right? Colleges, okay, institutions and institution, okay, in Tanzania offer engineering or scientific engineering and scientific programs, right? Programs under TCU, under Tanzania, so let me write in long terms. Tanzania Commission, yeah? Tanzania Commission for Universities, right? In abbreviation TCU, right? Study what? Study the course called what? Called the matrices, okay? Matrices and what? Basic calculus. However, that the name might be changed, as I explained, and I would like just to repeat. The names matrices and basic calculus. For example, in University of Dodoma, they call this module linear algebra. So in some other university, they might be calling any other names. But I'm telling you, I did fantastic and long time research. Believe me what I'm telling you. The contents are closely similar. And I want just to give you a brief understanding. Mathematics is universal. So even students in any country, who are pursuing engineering and scientific programs, they do study the subject of algebra, right? So for instance, that at MIT, Massachusetts Institute of Technology in the United States of America, they have a modules or the course called linear algebra. So linear algebra is all about matrices, because the concept, it has been titled as matrices, but will be studied. For instance, the first topic is called vector algebra. You see, so simply, so regardless of which name. So if you are under NATE, right, my advice, just stay there where you are, but watch also NATE modules in our online undergraduate institute of Tanzania, square bracket OLENJOLAIM. For instance, one of the modules is called calculus. In some of the universities, they used to call it Engineering Mathematics 1, Engineering Mathematics 2, Advanced Mathematics, Advanced Engineering Mathematics. So regardless of the name, the content, right? So this is just an overview for you before even we click the concept. But believe me that I'll be with you from the beginnings of this journey of basic calculus and matrices. I'll be with you. And God and I will be with you, right? That's the guarantee, because I can't teach without the presence of the Lord. Okay. After presenting that, I would like just to remind you, because this is the lecture 1, I would like to remind you that topics or chapters of 40 of matrices right? We have 6 chapters, matrices, endoting, and basic calculus. And I would like to mention them sequentially, right? The first topic that we have begun to, or I wrote it there, is called the vector algebra. So today we'll start to get in vector algebra, right? In vector algebra, and hence we'll see its beauty, right? And then the second topic, okay? The second topic, we call it in matrix algebra. Matrix algebra. Matrix algebra, right? Matrix algebra. Matrix algebra. And the third one, we are going to teach about determinants. Believe me, at University of Dodoma, they also used to learn these topics. Determinants, that's the same topic. You know about it. You have a great introductions of determinants. Then we are going to teach you about the first topic, which is, we'll be teaching you about complex number, right? Also, you know this if you are from, either you are from ordinary diploma or you are from advanced level. Then we have another topic is called limits and continuity. Limits and the continuity. Limits and continuity. Okay? Limits and continuity. The sixth and the last topic will do review of our best friend in engineering and science. Okay? Differentiation. And this will be the end of our journey. And I promise you that by the grace of God, we'll be together from vector algebra to the review of differentiation. In this module, or in this course, I'll be using the word, so when you hear the word module to myself and course, they are similar names, or similar words. Because in Ananate we call these subjects modules. And at TCU we call these subjects courses, right? So don't get confused about that. I might be using them interchangeably. Okay, so these are the 6 topics: vector algebra, matrix algebra, in my 2 schools and my 2 institutions. And you get them online, so don't worry. So if you forget, just read the descriptions, you'll see other links where you can get a quick review and brainstorm the concept. Again, the next one is matrix algebra. The prerequisite here, we have a topic called matrices in 4-4. We learn matrices also. We teach students matrices for the second year in ordinary diploma. I also do. And hence we teach, I teach matrices to the advanced student, right? In Form 6. It's a part of the topic called algebra, which is the 6th topic in the sequence of 10 topics. And then determinants. Wow. So determinants, the matrices, these are just, you know them. So you have a general introduction, but it will take you further. It means you'll be adding value to what that you have been known. Then complex numbers. This is a fantastic and beautiful topic of the Form 6. But also I used to teach complex numbers, and even as a teachers or even ordinary diploma students, yourself who is in undergraduate right now, you learn the topic of complex number during your either third year. Mostly in many institutions of undergraduate, they used to learn complex number in the year 3rd year, right? 3rd year. So in the 3rd year, 2nd semester. And I do teach also in another institution called the Online Diploma Polytechnic Institute of Tanzania, square bracket Olenjolai. There's limits and continuity. Possibly this might be a new topic for you. I know. When I was in advanced educations, I just learned the concepts of limits when I've been using a concept we call it first principle, the formula called the first principle. And then the review of differentiation, yeah, so you know, we introduced the differentiation for the first time. If you did the additional mathematics, you met it during your O-level education, ordinary secondary education. If you took a route of ordinary diploma, we teach differentiation for the 2nd year student, the 1st semester, until level 5. If you took a route of advanced education, also we teach differentiations during the Form 5, in advanced mathematics of the Form 5. And it's a 9th topic in the sequence according to the syllabus of United Republic of Tanzania. So you have not been wasting your time. So we want to add the value. So what are we going to do in this program? We'll be reminding you the very important and crucial concept that you've been learning through. And then we add the value, we add new concept, and we take you further, because now you are no longer an ordinary student or ordinary level student, ordinary secondary student. You are no longer advanced in secondary students. You are no longer ordinary diploma students. Now you are undergraduate students. So you have to think bigger. You have to think differently. You have to think to solve problems by using high intelligence. Stay connected. Do you love mathematics? Tell me in the comment section. Okay. So now let me present to you concepts. I call them concepts. Okay. Or before even concepts, I would like just present to you some of the specific objectives. Okay. Okay. Some of the specific objectives. Specific objectives of what? Specific objectives of learning vector algebra. Of learning what? Of learning matrices. So in general, matrices. Okay, you have to achieve this. So general, okay, we call them objectives of learning matrices and basic calculus, right? And basic calculus. Why do we want to teach you this stuff? The first thing, specific objective. And let me quote. I'm quoting from the course outlines of University of Dodoma. So, of the University of Dar es Salaam, excuse me. By the end, by the what? By the end of what? By the end of this course, a student, you can, will be able to, it's just like the syllabus of all level. Number one, students are basically to have, okay, students to have, I'm quoting, basically, I'm just underlining, it was not underlined, concepts, okay, let me just eliminate, basic concepts, and the computational techniques, and the computational techniques, okay, computational techniques. That's the first specific objective. The second specific objective, that computational techniques in algebra of vectors, matrices, and complex numbers and the application. So still continue. Okay, in algebra. Okay, in algebra of vectors. So we teach algebra of vectors. That's the first topic. Algebra of vectors and matrices. Okay, matrices and complex numbers. Complex numbers. Okay, complex numbers. So this is focusing in linear algebra before even differentiation. Complex number and their applications. So you should also know in their applications. Where do we apply? Their applications in science. In science and the engineering. Where do we apply them in science and engineering? That's the first specific objective. The second one, to introduce students into techniques to evaluate limits and extend them to differentiability. I'm going to introduce, and even other teachers, okay, to introduce students into techniques to evaluating limits and extent. Limits and extend them to differentiability. Extend these concepts to differentiability. Okay. So get prepared to enjoy the beauty of undergraduate mathematics in engineering and science courses. The third and the last specific objective of learning this course to develop the necessary techniques for differential calculus. Be helping you, or you as the students, you have to make sure that you develop, right? To develop what? The necessary techniques. For differential calculus. We'll be teaching you. Okay, to develop the necessary techniques for differential calculus. So, according to them, we call it a curriculum review or curriculum preparations which have been accredited by TCU. Those are the three main specific objectives that the students has to make sure that these are just a few specific objectives, but I want to promise you that you are going to achieve more than this specific objective when we get connected, or you stay connected with me. Then now, so let me take you on to subtopics of 40, or we call them subtopics, concepts. Okay. Concepts. Yes. Okay. Yeah. Subtopics. I'm not preferring the topic of subtopics. Concepts of 40. So I'm narrowing down the subject of vector algebra. What are we going to cover in vector algebra at the first topic? What concepts are we going to cover? So these are the concepts according to the course outline of University of Dar es Salaam. Number one, we are going to cover about the scalar quantities. So scalar quantities, we'll just touch little scalars, right? And then secondly, we'll take you on to vectors in 3 dimensions, and the meanings of R. Okay, R cubics, 3 dimension. Then we'll take you on to geometrical representation of vector, geometrical representation. We have to teach you representations of what? Of vector. Okay? Geometrical representations of what? Of vector. The first concept that we are going to teach you, we'll teach about addition and subtractions of vectors. Addition. So this is operations, addition and subtraction. However, that here we'll be teaching us geometrical representations of vectors. Okay? Then we'll be, okay, before even we teach you this operation, this is according to my sequence that God has given me. I will teach you about a subtopic called terminologies. Terminologies of what? Of vector. What the language of vector. What will be mentioned. Okay, and then the first one, I will be teaching about addition, how we can add. And then subtraction. Addition and subtraction of what? Of vector. Addition and subtractions of vectors. Well, so we have again the next concepts, very important, which we are going to teach you. of addition and subtractions of vectors, we will teach you about multiplications with scalars. That will be the sixth concept. Multiplications, multiplications of 40, multiplications with scalars. How we can take a scalar quantity and multiply with the vector quantity. That'll be another concept. All of these concepts, possibly none of the concepts which is new for those students who are from advanced educations. And I used to teach them in the advanced schools. My advanced is online school, that's called Tanzania Online Advanced Secondary School in square bracket Olenjolai. Then afterward, I will be teaching you Cartesian coordinates and vectors, right? Cartesian coordinates means that you're presenting a vector algebraically, Cartesian coordinate, and the vectors. Then the eighth concept that I'm going to teach you is this one, right? Unity vectors. I'll teach you about unity vectors. You know them. I'll just remind you. First three-dimensional, I, J, K. You know them. But possibly forgot, so remind because we'll take it further. Then I'll teach about dot product, right? Dot or equality scalar product. Okay? Also, we taught you this concept in ordinary diploma and also in advanced education. Afterward, we'll teach you about scalar and vector projection. Scalar and vector projection. That's another concept that we are going to teach you. Then the 11th concept will teach you about direction angles. Direction angles. Okay, direction angles. And number 12, and this is vector and scalar is what we call projection. We teach about orthogonal vectors. See, orthogonal means perpendicular vector, orthogonal vectors. So don't ignore, we are going to add some values. We are going to add some concept. Okay, for example, in dot product, we're going to add some new theorem for you, orthogonal vectors. And then now we'll take you on to very important concept. We call it cross product. Say cross product. You know this. You know. We have the introductions of it. Cross product. Say cross product. So cross product of what? Of vectors. Or vector product. And then we'll teach about the scalar triple product. This we don't know. Scalar triple product. Triple product. For we who did our advanced education more than 11 years ago, we learned the concepts of scalar triple product in advanced education or advanced secondary education in the topic of vector. The new syllabus, which has been in use since 2010, does not allow right now to teach students this concept. Students, they used to end in cross product. Fantastic, eh? But they have also another concept called vector differentiation, which for us we didn't cover it, we didn't learn it. Okay, then I will teach you about linear dependence. Linear dependence. Okay, this I know it's a new concept. Don't skip this concept. We are going in every concept that I'm mentioning. We are going to add, for example, that from dot product. So we are going to add new information that you have never heard. Okay, linear dependence and dot independence. Okay, independence. linear dependence and independence. And remember that these first concepts give you the general overview of the subject, right? So, and independence, okay? Linear dependence and independence. Then we'll teach about lines. We'll teach about vector lines in 3-dimensional, cubic, engineering, mathematics, and science. It means 3-dimensional. Then we'll teach about planes. Planes in 3-dimensional vector. So for we who did our advanced education in Tanzania more than 11 years ago, when I'm recording or when I'm teaching this module or this course, when I'm teaching this course, we used to learn these 3 concepts. Scalar triple product in advanced education, lines in 3-dimensional, and planes in 3-dimensional. What we need to study, we need to study about linear dependence and independence, right? And then, will it be the last thing? Vector products of 3 or more vectors. Last concept now, 18. Vector product, so vector product of 3, okay, vector product of 3 or more vectors, or more vectors. So we'll be teaching vector product of 3 or more vectors. That will be our last topic. So we said that the teaching style, okay, used to teach this course is what, okay, we'll be having lectures and whatever is divided into main 2 parts. The first part, we have something we call the lecture. And in lectures, okay, we have lectures. In lectures, we'll be giving you concept and few examples. But also in addition, I will be giving you homeworks. Okay? And then the second part, we'll be having tutorial sheet, right? Solving tutorial sheets. So in the class, you have tutors, you have tutorial assistants, but I'll be doing this business for you. I'll be teaching you lectures, and then I'll be solving respective tutorial question, right? So tutorial questions. It's quite different from the NAT learning style of competence-based question. There's no tutorial solving as independence. To me, that because in most of the universities, worldwide, there are lecture hours, and also the tutorial hours. But in some of the institutions, they don't have. They do combine that the teacher combine the lecture and solving tutorial questions simultaneously. Example, at the Algebra Institute of Technology, because I'm also teaching 4 modules or 4 courses at the University of Dar es Salaam of engineering and scientific mathematics. Can I mention for you? I'm teaching calculus for the first semester, first year student that we call NTA level 7A. I'm teaching also a module called advanced calculus, that is for the second semester, first year student, that is called NTA level 7A. Also, I'm teaching a module called course differential equation and complex variables for the first semester for NTA level 7B, it means for the second year. And finally, I will be teaching them, or the students all the students are ANACTE, that is the curriculums of the Algebra Institute of Technology. I teach a module called the Probability and Statistics for the second semester, second year students, right? So second year students. But for this one, but remember that for an TCU and the University of Dar es Salaam and all other associated universities that are using the same knowledge-based curriculums under TCU, I'll be teaching you matrices and basic calculus, the first course. Second course, I'll be teaching you several variable calculus that they for the second semester first year. This is for the first semester first year. And then the third course, I will be teaching you the course called the one variable differential question for the for the first semester of second year engineering students, College of Engineering. And finally, I'll be teaching a course called Statistics for non-majors, or Statistics for engineers and the scientists, which it has been taught at University of Dar es Salaam and all other associated universities, or all the universities in Tanzania, including Ananate, all the universities Ananate, all the universities under TCU, and even all the universities worldwide. We used to learn engineering or probability and statistics at the end of our courses, because we need them in many cases of solving engineering and scientific problems, right? So for University of Dar es Salaam and all the, as I said, that so I'll be solving these tutorial questions, right? Tutorial questions sheet, right? Tutorial question formatting from tutorial sheet. I'll be giving some of the questions so that you may solve and submit the homework in the comment section sheets. Okay? So that is what you have to expect, right? And that's what we are going to do with you. Okay? So let me spend a few minutes just to give you the overview, because we are still building the foundations here, right? And then I would like just to do or to present to you two things, and then we end this session. So we'll meet in the next lecture of 40 of calculus of matrices and basic matrices and basic calculus. Okay. So as we say, the first concept that we have to cover is a scalar quantity. Scalar quantity or scalar vector and quantity. Scalar, yes, scalars, and then vectors, and then we dig into vectors. We'll be presenting something that just like a reminder. So let me begin with scalar. Scalar. First of all, we have something called a physical quantity. So the word scalar and the vector are come from the word we call the physical quantity. Say physical quantity. And this physical quantity used to learn it seriously in physics, because in physics we have fundamental physical quantity and derived quantity, right? So we have physical quantity, and they have some called units. So in physical quantity, we have two types of physical quantity. We have scalar physical quantity, we have vector physical quantity. And we introduced you for the first time in physics form theory, right? Scalar and the vector quantity. So now, let me remind you, in mathematics, scalar quantity. Scalar quantity. We call it scalar quantity, that's the name. And the fundamental question, which is common for you, which is the first question, you have to ask yourself, what is the scalar quantity? Pause the video, define, okay, scalar quantity. You should have this mind as an engineer or scientist. What is scalar quantity, right? Pause the video, ask yourself, what is scalar quantity? Do you still remember something in your mind? Then write down, then continue to watch the video, right? Scalar quantity. Scalar quantity, right, is the any physical quantity. Is the any physical quantity. Is the any physical quantity which have or has, which has only magnitude. or gives only magnitude. Magnitude of what? Of that physical quantity. So scalar quantity, I'm not teaching you physics, I'm building the foundations. Today, in lecture 1, lecture 2, lecture 3, I'll be building the foundations of vector algebra, right? Of 40, of, this is the general introductions now of vector algebra. So we said that the general introduction, so this is the general, so we are still in the process of general introduction. Okay? Again, I would like to remind you, in case that you've been touched by God and you want to offer God, not Olenjolai, and not even my programs or my ministry, my teaching ministry, right? Offer God. You are free willing thanksgiving for what He has brought in your house and for what He has brought in your ghetto or in your room, right? In your bedroom, so in your hostel or in your class, right? From distant apart, very worthy thing. So you offer Him free willing thanksgiving, and in case that He will direct you, or will tell the Lord Himself will tell you that to offer it through this platform, you are warmly welcome. We receive free willing thanksgivings, and your free willing thanksgiving will be used to pay for the running cost of these programs. It won't be used to run my own life. No, God, I have some other source of income that God has given to me, right? But we used it to run this program. It's very expensive to bring this program in your hand, more than you think. It's very expensive, right? Very expensive. However, that I've decided, and even God has told me, to offer it free to the serious students in a year. So that the instructions I have right now, and really I'm loving. I love what I'm doing. I love to offer these contents to the millions of present and future generations. So if you have two ways that to send to me, okay, the chief executive and even the founder of these platforms of Tanzania, of Online Undergraduate Polytechnic Institute of Tanzania. So you may send by using mobile transactions 0759745331, or you may use the bank transactions, and the registered name is Olenjolai TAYAI. No need to send a message or to call, right? And then if you want to use the bank transaction, click the buttons below this video that is written "Show More," so that you will read the descriptions and you'll see the bank account, bank name, and even the bank accounts and bank name and bank type, which is NMB. And your free willing thanksgiving will be accepted by faith in heaven, and my God will bless you abundantly, and even will increase and make sure that His covenant is everlasting and it's eternal for the rest of your life and your generation. May God bless you. Okay, so let us come back. So it is the any physical quantity, right? Which has, so here we have a pause, only magnitude of the physical quantity, of that physical magnitude, right? Of that physical quantity, of that physical quantity. Well, next question. What are the examples of scalar quantity, right? You know some examples of scalar quantities. If you refer your physics, examples of scalar quantities are the following. The first one, distance. Distance is the scalar quantity because there's only magnitude, it doesn't show a direction, right? Then the second one, we have to begin with the simplest one. Speed, say speed, that's the scalar quantity. Then the third one, we have again a terminology that we call speed. We have speed as a speed, and then we have a speed. Can you mention some other? We have mass. We have money. Mass is a scalar quantity. Then we have money, which in Tanzania we have T shillings, Tanzania shillings. It's a scalar quantity. Then another one is what? Density is a scalar quantity, right? And then another example is what? Temperature is a scalar quantity. Temperature is a scalar quantity. Then number 7, time is a scalar quantity. Then the 8th example, right? The 8th example. Pressure. No. No. Is it pressure? No. I don't agree with that. Time, intensity of light. Yeah, okay, intensity also has direction. So these are the some examples of what of scalar quantity. So you can add more examples as well as you can. Okay. Again, the next question now, we said that in physical quantity we have two types of physical quantities, which are fundamental physical quantity and scalar, and the derived physical quantity. But also we have two types of what of fundamental. We have only one type. In fundamental we have scalar quantities. Okay, but in derived physical quantity we have scalar physical quantities and what vector physical quantity. Right? So then we have the topic is called vector algebra. So what is vector quantity? So that the next question. What is vector? Right? What is vector? Vector quantity. Let's say it begins from the big picture that you have, vector quantity. So the fundamental question is, what is vector? What is vector? Right? What is vector? I found two definitions. Okay, you can find more than two definitions, but I just chose two definitions to present it to you, which will remain or will be sticking in your mind for the rest of your life. Okay? So I say that what is the vector? Or the term, or define the term vector. A vector, remember we are learning mathematics, we are not learning history. A vector, so will come into computations, don't worry, is any physical quantity. A vector is any physical quantity, which can only be described, can only be described full by its magnitude. Full by its magnitude. Full by its magnitude, which is in other words called its size, right? And the directions of its effect. And the direction of its effect. Its effect. This is one of definition. So is any physical quantity again, but this physical quantity can only be described in two ways, or is in two parameters. The first one is a physical quantity, is the magnitude or size of that physical quantity. And the second one, which is missing in scalar, is direction of its effect. What are the directions of its effect? So we say scalar, for instance, that we want to move from point A to B. So means you are moved from A to B, but we don't show the direction. This is distance. Right? For example, you want to move from Dar es Salaam, right, to Dodoma, headquarters of Tanzania. Then you are moving from Dar es Salaam to Dodoma without showing direction. So this is what scalar quantity. So this is still what you are talking about. The distance between Dar es Salaam and Dodoma, possibly maybe is 400 kilometers. Right? 400 kilometers or 450 kilometers. So there you have mentioned the distance, not the vector. The vector, you have to say that a distance from Dar es Salaam to Dodoma is, for instance, 400 kilometers in western of Dar es Salaam. So western indicating direction, right? Again, some of the references define vector extraordinary, that a vector is any physical quantity. A vector is any physical quantity. A vector is any physical quantity which has both. Simple definition, which has both. So you can pause the video and ask yourself what the meanings of vector, which have both, because you can be learning about vector algebra, and hence your child, your future child, will ask you, father or mother, what is the meaning of algebra or of vector? And then be having, you'll be shocked because you don't know in direction. So vector is any physical quantity which has both magnitude and what directions. Okay? The next question, you can pause the video and mention some examples of what of vectors. Okay, examples. So examples of vector, the first fundamental example is displacement, which we are going to cover in this topic, displacement, right? The second one is velocity, right? Velocity. The third one, we have so many vector quantities, and these vector quantities, we use them in engineering and science. The third one is acceleration. Acceleration, right? So this is single acceleration. And then even deceleration. The fifth one is force. That's working, okay? The sixth one is momentum. Okay, momentum. Then another vector quantity is torque, right? Is torque, okay? Is torque. So here we are talking about, so it's torque. So another one is torque. Say torque. This is for circular motion, rotational motion. And then another example is what? Is angular momentum. Angular momentum. Angular momentum. Some other examples again. We have force, we have pressure, we have momentum. Okay? We have fantastic examples. Yes, so we have electric field. Electric field. Okay, we have electric field, and also we have magnetic field. So we are going to show them magnetic field. Okay, magnetic field. So those are some examples of what. So if you count this 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 10 examples of what? Of vectors. So when you be learning about science, applied science, or engineering, right? In mechanical engineering, civil engineering, electronics engineering, telecommunication engineering, computer engineering, you see? Even we have also some other mining engineering, industrial engineering, chemical engineering. So we'll be finding some physical quantities which are applicable in our fields, which are vector quantities. So that's why we are teaching you this concept in advance. The last concept before I end this concept, or I end this lecture, I would like to teach you about notation of vector. How do we notate vector? I'm not sure that if you still remember about notation of a vector. How do you notate a vector in mathematics and engineering, right? So we say that there are three basic notation. There are three basic notation of 40 of a vector. Can tell them three or more than three. The first one, notation by using two capital letters and arrow above them. To notate a vector notation by using two capital letters, right? Capital letters, and these are the English letters with what? With an arrow. With an arrow above it. And this we find when we learn this about displacement vector. For example, the example of positional vector, we can have positional vector OA, and then we have an arrow. So this is the first notation. We can have a positional vector B, so we write OB. We can have positional vector C, we write OC. We can have displacement vector AB, we can write this one, we have an arrow. We can have a displacement vector BC, we have an arrow. We can have a displacement vector AC, have an arrow, so etc., etc. So you see, and what does this mean? We can find magnitude of this vector, right? But this arrow indicating direction, say direction. An arrow at the top of those two letters indicate what the direction of the vector. That means that the initial point of this vector is O, the final point is A. Initial point is O, the final point is B. Initial point is O, final point is what? C. Okay? And then initial point is A, final point is B. Initial point is B, final point is C. Initial point is A, final point is what? Is C. Okay? So is that the case? That's the first notation, right? And we'll be using it often. The second notation, we can notate by using, we call it very important. Let me check it, cross-check notation, using lower cases boldface type. So in typing, we can use we can use notation of a vector by using lowercase boldface type. Lowercase, so lowercase, okay, we call it lowercase boldface. Lowercase boldface. Boldface type. Don't worry about this phrase, okay? Boldface type. Example, we can notate vector as vector A, but we use a bolded A. So this we call it a bolded A. Say bolded A. So this the bolded A. Can also use this the bolded B, right? However, that we don't use, we use this one when we are typing a vector in a computer, right? So this is bolded C. But lowercase, you cannot use any bolded A like this one. This is not allowed in vector, right? So this is not allowed. So etc., etc., and there are some special letters. But the third notation, we say that you can notate a vector, notation of a vector, okay, of a vector, notation of a vector. We say that in handwritings, where boldfaces type is either unavailable or unwidely, vectors are often represented with writing vector, okay, notation of a vector by using, okay, vectors are often represented with right pointing arrow notations above their names. I've discussed about that. Short notation of vector may also include tied, okay, by using what? Tiles, okay, and a straight line, right? Tiles and the straight line. And straight lines can use either tiles, okay, tiles, or you can use a straight line, okay. And this we have to write them above or below the name of the vector, above or below the name of a vector. Okay? So let me give you an example, because with examples we understand stuff. With examples we simplify complex issues in engineering and science. So with examples we enjoy the beauty of engineering and science, right? So then let me give you examples. So examples, and let me clarify them. Notations is tiles, right? Tiles above what? Above vector name. So this one, we have some examples, and these examples that we can have vector u, and then we have a waveline, or vector v, then we have a waveline, or we have vector uv. We have possibility that another common later is what uv, and we have vector s is less commonly. Yes, for instance, this, because also we have special letters for the anti-vector. So that is what in tiles. So this is if you use the tiles notation. Okay? And then we say that tiles. So again, we say that we can use a straight line above. We can use a straight line above what? We can use two letters above a vector. Okay? So in this one, examples, you can have vector u, and then you have a straight line like this. Then you have vector v, you have a straight line like this. No, under, not above, excuse me, under. Hit under, let me confirm. Below the name of the vector. Below the name of the vector, right? So we can have this straight line, like this. But also, in addition, these tiles can be above or below. I thought below. For instance, we can have vector A, then you have this. Vector B, then you have this. Vector C, then you have this. Direction of vector I, etc. So those are the notations. Okay? U and what U and V. So tiles like that ones. But also we can say that here I can add some additional examples. It's not necessary that we can use only two letters. For example, we use this notation to notate electric field strengths, and also use these notations to notate magnetic field strengths. So all of them are what are vector quantities. And this is the notation that we are going to use interchangeably for the rest of our life in artists and basic calculus. So this is the end of lecture 1. I thank God who have been with me during the preparations of this program. Real God has been faithful in preparations because He really prepared me, and I thank Him, and I give Him all the glory and all the honor. I thank God also who have given you opportunity to follow me, to get connected, to have this important information for the rest of your life. And I thank God who have let us to meet at this right time. And we are ready to cooperate in order to solve our own real life problems. And also I thank God who have impacted the present and future generations through this program. So I would like to invite you in lecture 2 of 40 of vector algebra. And I would like to tell you, do you know what am I going to teach you? I'm going to teach you about inverse. Thank you, God. I didn't leave the homework. So the homework I'll be using H/W. This is homework 1. Homework 1 is this one. We have 2 questions, right? The first question describe briefly, okay, the dimension of a vector. What dimension of a vector? What remains of a dimension of a vector? Okay, and then secondly, we said that you mentioned two types. Mention types, not two. Types of what? Of dimension. Types of dimension in vector. So make sure that you do this homework, and you have to submit your solutions in the comment sections of this video. Okay? So I thank God. When I've been giving you thanks, He reminded me that I didn't leave the homework. In every lecture, I'll be leaving a homework. In every tutorial that I'll be solving, I'll be leaving a homework. So you have to love doing homeworks, because I want active students. I will make you to be active, believe me, and I will make you to be serious if you are not serious. So these programs will transform your life, and that's why I call it you think differently, right? So, so I would like to invite you in the next lecture. You know what am I going to teach you? I'll be teaching about the terminologies of vector algebra. So I'll be teaching possibly 9 to 10 terminologies, which are very important. We'll be using them, we'll be referring them as long as we continue this program. So I will invite you, don't miss it, in lecture 2 of terminologies of vector algebra. So may God bless you. Make sure that you subscribe. Remember to subscribe to our YouTube channel. We are going to have more than 400 videos we upload in this channel. So make sure that you don't miss it. And may God bless you, and share these contents with your classmates, with your friends. Also ask you questions in the comment sections. Don't forget about that. And then may God bless you and keep you safe until we meet in section 2. Olenjolai loves you so much.